Test 4, Part 1, Passage 1. Listen to a conversation between a student and her professor.
Hi, Professor Jackson. You mentioned that you wanted to see me. Is this a good time?
Sure, Jamie. Why don't you come on in? I'm just looking over some notes from my speech tomorrow.
Is it for the Russian Literature Conference that's happening on campus?
Why, yes. I'll be speaking about the early works of Tolstoy and Dostoevsky.
Oh, I read a book by Dostoevsky in high school, but I'm not sure about Tolstoy.
Well, I'd recommend any of their books wholeheartedly. Anyway, I wanted you to stop in because I wanted to talk about the quality of the 2 assignments you've turned in so far.
Yeah, the grades I received on them were quite different, to say the least.
That's what I don't understand, Jamie. The first essay I got from you, the one that discussed an anthology of first-person accounts of World War II, it was by far the best assignment anyone in my modern European literature class has submitted.
I appreciate the compliment. I'm a bit of a history buff, and I've done a lot of reading about World War II on my own.
I'll say. But then there's the matter of your second essay. We were discussing French literature at the time, and you wrote about...
Existentialism. I read The Stranger by Albert Camus.
And you focused on how existentialism influenced Camus.
Yeah, I thought that would be a good way to learn more about how Camus thought.
But, I don't mean to be overly critical, but the essay you wrote was rather unorganized. And as I was reading it, I never really felt convinced that you grasped the topic.
Well, to be honest, I'm not sure if I understood the idea thoroughly enough. I guess I ended up just writing about the research results in general because I wasn't sure what was important.
I see, Jamie. I'd have to say, first, I recommend conducting a lot of research. Second, I guess it's clear that you'd have to come up with your own conclusion about the topic before you actually start putting your ideas on paper.
Yes, but, I've been overwhelmed lately.
You mean with my class?
No, just in general. See, I'm taking 18 credits this semester because I hope to finish my graduation requirements early and start grad school. Since I'm studying lit, that means I have at least 1 or 2 essays a week to write.
So you didn't have enough time to spend on the assignment you turned in?
Right. I really tried to do the best I could on it, but I was barely keeping up.
Jamie, I realize I'm not a guidance counselor. You know, I was also a very driven student once, so I understand. However, you really have to take a different approach. Think about training for a marathon. You have to run every day to prepare your body. You can't just train 1 or 2 days before the race. Completing your assignments is the same thing. Try to squeeze in 1 or 2 hours of work each day instead of trying to finish it all off in a single day, and you won't get stuck feeling overwhelmed.
That makes sense, and honestly, I've never managed my time well.
Well, practice makes perfect. I really hope you take my advice.
Oh, I will, Professor. Thank you.
And while I have you here, you know that first essay you wrote?
What about it?
I'd like to submit it to the university's undergraduate literature journal. Each professor is allowed to nominate 1 piece of student work every quarter, and I think your piece deserves publication.
Really? Wow, I'd be honored.
Great. I'll email you a release form. You need to give the journal permission to print your work. I think the editors may want to send you the essay with possible edits as well. Are you okay with that?
Sure. I've never done that before, but I'm willing to do it. I'm actually heading home, so I'll take care of it right away. Thanks, Professor.
No problem, Jamie. Have a good day. Now get ready to answer the questions. You may use your notes to help you answer. 1. Why does the professor want to talk with the student? Two. What are 2 criticisms the professor gives of the student's second essay? Listen again to part of the conversation, then answer the question.
Right. I really tried to do the best I could on it, but I was barely keeping up.
Jamie, I realize I'm not a guidance counselor. You know, I was also a very driven student once, so I understand. However, you really have to take a different approach. 3. Why does the professor say this? Jamie, I realize I'm not a guidance counselor. Four. What is the professor's opinion of doing assignments? Five. What will the professor probably do next?
Test 4, Part 1, Passage 2. Listen to part of a lecture in a chemistry class.
Good afternoon, everyone. I'm hoping most of you had a chance to do yesterday's reading about phase changes. You should remember that phase changes are when a solid, liquid, or gas changes into a different form of matter because of pressure or temperature changes. Today's talk is going to cover some of the same ground, so you might get lost if you didn't do the assignment.
Well, I read the material, but I'm a bit confused. Does all this phase change stuff mean, like water, for instance, that water has a boiling point that is constantly changing?
Not quite. So let me try to explain what these phase changes are all about. First, I want you to think about a pan on the stove that's got some water in it. Got it? Good. Then, when you first turn the stove on, how is the water being heated? Through convection, right? The surface of the pan is in direct contact with the water, and the heat waves travel through the water. This rise in temperature gets the molecules on the top of the water energized, and they evaporate. So, they turn from liquid water into a gaseous water vapor. Eventually, the temperature gets high enough, and we reach the boiling point, 100 degrees, right? And these bubbles start to develop from the bottom of the pan, the heating surface, at different sites called nucleation sites. This is a phase transition, by which some water molecules transform into little bubbles of vapor, generating a type of boiling called nucleate boiling. Now, before the water was boiling, molecules on the surface of the water were changing from liquid to gas. But with the increased temperatures, now molecules from all parts of the water want to make the change. This is why bubbles form. The higher the temperature gets, 150, 160, 170, the more active the water becomes and the more rapidly bubbles start to come up. So, after a while, it ends up that water doesn't just keep boiling the same way as the temperature keeps getting higher and higher. Here's where another transition comes in. Once you hit a certain temperature, around 200 degrees, then the behavior of water starts to change. At this point, so much vapor is being made on the bottom of the pan that it starts to form a layer between the surface of the pan and the water itself. Instead of popping to the top of the pan, the vapor just stays at the bottom. This period of time, as the amount of bubbles begins to decrease and the vapor trapped at the bottom increases, is called transition boiling. Soon enough, the bottom of the pan becomes completely filled with a layer of vapor, and the behavior of the water, or any liquid for that matter, completely changes. Does anyone know what this effect is called? It came up in the reading.
The Leidenfrost effect, right?
That's correct. Let's talk about this a little bit more. In the case of the Leidenfrost effect, which leads to a third phase transition into what's called film boiling, by the way, the layer of vapor stops the water above it from being heated very efficiently. Vapor's not so good at convection. What ends up happening is that any water that happens to touch the bottom of the pan at such high temperatures vaporizes immediately. This builds up the vapor layer, which is about 0.1 or 0.2 millimeters thick. And then, as some of that vapor escapes, new water from the bottom gets transformed into vapor again. Because the heat transfer is so inefficient, the water evaporates at a much slower rate than at lower boiling temperatures under 200 degrees. Here's an experiment you can do at home which might clarify things a little. Take a pan, hopefully not a good one, and heat it up on the stove. After a minute or so, put a drop of water in the pan. What happens to it? It hits the surface, spreads out, and evaporates quickly. This is because it hasn't reached the Leidenfrost point yet. Then, turn up the stove to its highest setting and let the pan sit a few minutes. Now, put a drop of water in the pan and see what happens. It doesn't break apart. It stays intact for a long time and skitters across the pan. This is because of the Leidenfrost effect, which causes only the bottommost part of the droplet to vaporize. The rest of the droplet is supported on top of the vapor layer and is protected from the full heat of the pan. Finally, after a minute or so, it'll vaporize enough that it completely evaporates. Why is this effect important? I'll give you a couple of real-life examples that can show us some applications. Have you ever seen people walk on hot coals? What's happening is that the coals are superheated, just like the metal of our pan. When the coal walker, he's got to have wet feet to do the stunt. When he walks across the hot coals, only the water nearest the coals vaporizes, but the water touching his feet stays liquid. The vapor creates a kind of protective layer that prevents his feet from being burned. A more modern scientific application of the effect is increasingly seen in the computer industry. As computer processors get faster, they must be cooled to function properly. Researchers have found a way to use the heat produced by the chips to move a special coolant around the top of the processor to cool it off. By setting up special stairway-like guides for the coolant liquid, the researchers found that the liquid would actually move up inclines due to the Leidenfrost effect. This way, they can use the inclines to push the coolant in one direction and collect all of the vaporized liquid with a condenser, which then turns it into liquid again. The beauty of the system is that it doesn't use any extra electricity or energy. All it takes is the Leidenfrost effect and the hot air near the computer processor to move the coolant around. See, from firewalking to your stove to the inside of your computer, the Leidenfrost effect is all around you.
Now get ready to answer the questions. You may use your notes to help you answer. 6. What is the lecture mainly about? Seven. According to the professor, why do bubbles form during nucleate boiling? Eight. In the lecture, the professor explains the sequence of changes a liquid undergoes as it is progressively heated. Put the steps listed below in the correct order. 9. According to the lecture, why does water evaporate slowly during film boiling? Listen again to a part of the lecture, then answer the question.
The rest of the droplet is supported on top of the vapor layer and is protected from the full heat of the pan. Finally, after a minute or so, it'll vaporize enough that it completely evaporates. Why is this effect important? I'll give you a couple of real-life examples that can show us some applications.
10. What does the professor imply when she says this?
Why is this effect important?
What can be inferred about using the Leidenfrost effect to cool computers?